This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
For Software Engineering Radio, this is Robert Blumen. My guest today is Derick Schaefer. Derick's career has included a decade-long tenure at Microsoft and roles as CTO and VPE at multiple SaaS companies. Derick is the author of the recent book, CLI, A Practical Guide to Creating Modern Command Line Interfaces. Derick, welcome to Software Engineering Radio.
Robert, thanks for having me on the show.
Before we get to talking about modern command line interfaces, is there anything you'd like to say about your background that I didn't cover?
Well, I'm now entering post 30 years. My career has been a combination of technical leadership roles and leadership roles in software, but I've never really lost my roots as a software engineer and a data architect. And to be very honest with your listeners, that's the thing I always gravitate towards because it's the funnest part of the job.
Yeah, I think many listeners to our podcast feel that way. Now, in your book, Modern CLIs, you tell a history of the CLI, which I found very insightful. I think a good place to start would be, what is a CLI?
A command line interface is an interface into a computing environment, right? That is predicated on a terminal and generally a shell. And the terminal gives access to the computer. The shell enables both scripts and programs. And these programs, or these CLIs, are literally built to do discrete pieces of work inside of an operating system, whether it be at the operating system level or with a business application.
Give a couple of examples.
Sure. If we date ourselves back to the 70s, the classic command line interfaces of grep, which is a filter for text files, sort, which is an ordering filter. You've got cat, which is a pipe out into standard out type command line. Those are tried and true age-old command line interfaces. If we come into the modern era, there are command lines such as GH, which is the GitHub command line interface counterpart to its GUI. Git, obviously, the WordPress ecosystem features the WP CLI, which is a modern command line interface. So you'll find them in all forms and fashion, but they do have some commonalities, at least the good ones that have survived the test of time.
When I picked up your book, I was expecting something more like the modern use cases you gave for CLIs. I always thought those old school things like grep were commands, but maybe I'm like that famous character in literature who was surprised to learn he had been speaking prose all his life. Is a command and a command line interface the same thing?
That's a great question, Robert. And the short answer is no. You have commands, right? But the command line interface is the gateway into the computer, if you would, that would invoke those commands. So historically, we went from punch cards as the interface to invoke functionality and commands to a terminal, which was a gateway into a shell that enabled access to scripting environments and commands. And then obviously in the modern world, we use graphical gateways such as applications and browser-based apps and mobile apps.
I have been in the field probably about as long as you, and I see commands in a certain way. You have an interesting history of the CLI. Tell us that story.
Yeah, so I chunked the history up and purposely in the book did not want to get into the dredges of every little incremental innovation in the terminal and command line history, but we chunked it up into basically 4 or 5 parts. The first being the early years where they gained momentum as we transitioned from punch cards into an actual teletype interface that allowed users to type into and view their output first through a printer and later on the terminal. We then saw acceleration in the Unix world as we began to see both terminal as well as shell innovations, and we got momentum. The real dark era for the command line was in the 90s when the popularity of the GUI really started to rise. And the question was sincerely asked, do we really need command line interfaces to a computer? Can we not do it all through a graphical user interface? And the short answer to that was no. which led into the Unix era, which was the revival of what had been built in the Unix era and brought life again to command lines. And then we started into the modern era to where the innovators who have built modern command line interfaces have really done some amazing things. So that was the way we chose to look at it and wanted to kind of set some context so that the readers could understand where this came from and what were the major catalysts that caused for the changes that we've seen today.
Your story is the rise and fall and rise of command lines. They're back and bigger than ever before.
They are, and they're back at scale. So if you think about the command line of the past, the 70s and 80s version, it was used by power users, it was used by administrators, and it was used in what I would call high-value environments. You had one administrator, a few high-dollar machines, and it was a very kind of protected access to a machine. If you fast forward to today, every developer has access to shells, terminals, and they have access to command line tools such as Git, GH for GitHub, Docker, Kubernetes. Each of the major cloud providers offers a CLI. These things are really a powering force in our productivity and workflows today, and I think that that's really cool.
I have a question in my outline. We've been talking about this already a little bit, but I don't think you've told us exactly what is modern about modern CLIs.
Yeah, so there's a couple aspects to that. I'm going to start with the most basic, which is what we would call the command model. And if you go back to the early days, the Unix philosophy really stated that these command lines should do one thing really well and play well with others. So you saw commands that were created for a specific purpose. If I were to come up with a hypothetical example of for a CRM application, a simpleton command line would be CRM add, right? We would add a customer and it might take an argument and we might have a few switches that would give some additional functionality. Well, with that mentality, design-wise, you'd also have to have a CRM delete, a CRM change, a CRM list, and you can see where the duplicity in the code and the management of that becomes a real problem very quickly. So in that traditional world, you saw the command line evolve to have arguments and then a more organized set of switches that would allow a single CLI to do multiple things. So put that, Robert, in a bucket is the traditional. When Linus Torvalds introduced Git into the ecosystem, he took some best practices out of a few different worlds and introduced what we now refer to as the object command model. And it is literally a command and subcommand model that is usually organized around either a noun verb or a verb noun. So if I were to take, for example, the WP CLI, which is WordPress's command line interface, everything is organized around the noun, a plugin, a theme, core, and then it's followed by a subcommand that's a verb. The reason why this is so innovative is it allowed very complex command line interfaces to be built and have the code isolated almost like we would a microservice in a SaaS environment. And it allowed reuse of centralized code and global flags and just really, really robust organization of the application. And that is the preferred model today, is the object command model. Even though there's still modern CLIs that are written traditionally, that's what we see today. So that's one aspect of it.
If I could think of an example of the old Linux admin commands, user add, user mod, I forget if there's a user del. Now, if that were written today, it would be one command user, and there would be sub-commands add, remove, edit. Did I get that right?
There would. So I would almost organize that traditionally and say that user, right? And then the argument could be a username or an ID. And we would have switches that would be like an action equals add delete, or we could have a -- add, a -- delete. If you were to think about the Unix operating system or the Linux operating system holistically, you might have a general command like we do with MySQL, to where you're going to have objects inside of it, which could be nouns, and then verbs that follow. So an object could be a user, add. An object could be a package, add or delete. An object could be a networking protocol, add or delete. And so you can see how that would allow a single command line, whether it be in a REPL, which is a shell like MySQL, or strictly at the command line to do a lot more things in a very consistent way. And the key is we got help out of the man pages and got them into the command line so that the user can actually see all of the options and configurations that are available to them without having to bounce in and out of man pages or other documentation.
So what you're talking about now, the built-in self-documenting feature of most modern CLIs?
Yes. And that was significant. It, once again, had been introduced in bits and pieces, but Torvalds really popularized that with Git as we brought all of that into the CLI itself.
You mentioned Git a few times, and in your book, you state that it was highly innovative in the CLI space. What were some of the great innovations that Git brought the CLI world?
So first of all, if you think about scale, the original CIL mantra was with inside of an operating system, and it might venture its way, something such as rsync, to where it's going to communicate between another machine. But when you look at Git, we are talking about local and remote connectivity and the ability to manage both sides of the repository equation at scale across hundreds of millions of users. It really thought this out in a way that, though people will run into their challenges with their repo, you don't see the challenges of repository management of the past, to where code is lost and documents are, overwritten. They really got that right at scale. And I think that was a very modern forethought on behalf of the designers and the maintainers today, is to make this work at scale.
Something that I think of as the modern CLI is a command line tool for calling an API. You call this the API first architecture. What do you mean by that?
In distributed computing, right, we have gravitated from using SDK functional calls locally to calling APIs. So the modern command line interface finds itself more organized around making these remote calls versus calling an operating system function, or versus calling a function from a local package that might be compiled into it. Though that's still fair game for the function of a CLI, we see a lot more remote communication with APIs in kind of a more modern sense. And to be honest, any CLI designer really needs to think about leveraging, once again, the Unix philosophy, do something well and play well with others. And part of that play well with others has extended from standard in, standard out to being able to make an API call out and receive data back in as a part of that work stream, if that makes sense.
I think so. I think that your point is we're not just pushing text around through a pipe on the Linux file system, but we're going out over networks and consuming networked services in the same pipelines. Is that where you were going?
That's exactly the point I was trying to make.
Suppose I have a great API that I set up for my customers or users, and then there's an SDK, and now I want to add a CLI. Should the CLI simply mirror the API structure, or do you think about it as a different use case?
I hate to give an answer like this, but it does depend. I would go back to classic UX mantras of what is the persona you're trying to serve and what is the purpose of the CLI. So CLIs can be used for a number of things. Traditionally, they've been used for administrative tasks. They've been used for power users. But I'll give an example. I'll pick on the WordPress CLI again. WordPress itself, as a PHP and JavaScript primarily driven user interface, had challenges with longer running tasks. So things such as regenerating images on a site was a real problem. And the WordPress CLI specifically leverages that infrastructure within inside of WordPress core, but they made their own decisions in terms of performance to be able to accomplish the task and not be victim of some of the shortfalls that the graphical user interface implementation would have. And they crushed it, right? That's the de facto way to go regenerate images on an entire site, is through the CLI, because they did it in their way to solve the need for the persona that they were servicing.
You just now mentioned long-running tasks, something I wanted to ask you about. What is the model or interaction models for CLIs to handle long-running tasks?
It depends on what the long-running task looks like. So first of all, when we talk about interacting with APIs, one thing that is a headwind in any type of SaaS environment is if you look at your edge providers or you look at your global traffic managers or even local traffic managers, they are not in the business of holding open TCP connections for 5, 6, 7, 10 minutes, right? It's a real problem. It's a resource problem that they manage to. So if we think about those tasks of let's take about churning through data. If we've got a data set to process that is 100 gig, 500 gig, a terabyte, and literally has tens of millions of rows, that running task needs to be mindfully thought out in terms of how we chunk that up and what are the system level programming resources that we leverage. So in that file example, if I were to look at that and I was sitting on top of a 4-core or an 8-core machine, as a CLI designer, my first thought is how do I divide that file up into 8 parts and concurrently run a process on that to leverage that multi-core machine. The second is how do I efficiently leverage the memory that I have locally in a way that I'm not thrashing on the disk. In the C++ and in the Go world, the map type, right, which is kind of a hash bucket element in memory, has really evolved in recent years. And Google's patent on what's called a Swiss table, which allows for an 8K descriptor on the bucket, allows you to really, really leverage the memory that's available on local machines and use that to speed up process. So back to your question of what does a long-running process look like in a CLI? First of all, you want to shorten it as much as possible in a responsible manner. And then to the extent that it's going to have to continue to be longer or run over periods of time that might be subject to interruptions or failures, you're going to want to go back to tried and true design tactics, such as having breakpoints, recovery points, being able to do retries, and not lose that work that has been in process. So I always go back to my friend rsync. I cannot tell you how many just challenging situations rsync has gotten me and coworkers of mine out of. And that's a good one to go look at to say, if we're going to run something for a day, 2 days, a week, boy, it sure is nice if you come back to it and something went wrong to be able to start where you left off.
All of what you said, certainly very relevant. Not the question I had in mind. So let me ask you a different question, which is, what about a task which it doesn't necessarily involve a staggering amount of data, but I kick it off and it's going to take the provider 2 hours to do? What is a model for that?
First, you're going to have to be in a resource environment that will allow you to do that. So if you are simply waiting for the provider, let's say that we put a call out that says, I need X to be done, and that could be, chinning up a bunch of clusters in a cloud environment. You're going to want to wait, right, in a responsible way, in a non-blocking way for that command to execute. And you're going to want to be able to make some decisions along the way as to whether you think that process is ever going to complete. So in the Go world, this would be a combination of spinning up a Go routine and associating that with a wait group. And so let's double down on your question and say, what happens if we ask something to do 100 things and needed all of those to come back? We could have those assigned to 10 Go routines to 10 wait groups, and one by one be able to check those off as they completed and maintain a state of waiting until we finish that. And we'd also mindfully need to make some decisions if we thought something was going to error out or not happen to be able to restart it or retry it.
You mentioned Go just now, which ties into something else I want to ask you about. I'm pretty sure the Linux commands we talked about were all written in C. You're talking about Go as another choice. What are the popular implementation languages in the more modern space?
So you are still seeing modern CLIs written in C and C++. In the book, we have a spotlight section where we spotlight a handful of really large-scale popular CLIs, and 2 of them, one represents C, which is Git, and the other represents C++, which is Ookla Speed Test, which is a really nifty CLI. But you're also seeing CLIs written in PHP, Python, Node, C#. All of those have some challenges with them because of runtimes and the overall plumbing that surrounds them. But the new kids on the block of Go and Rust are gaining popularity. GitHub is an example that GH was written not only in Go, but uses a package called Cobra, which is an object command framework for Go. And we also highlight a terminal. It's not a CLI, but it's a smart terminal called Warp that was written in Rust. In my view, the more you can leverage system programming power in a language, but not have to manage the overhead of multi-threading and memory management like we had to traditionally with C and C++, and the lighter weight the runtime and footprint is, the better of an application that programming language is going to be. And I am certainly a fan of Go from that perspective. Give a huge nod to Rust, but I've also been active in the WP CLI ecosystem where PHP is the language of choice.
Derick, you just now mentioned Go and some of the tooling that exists to support building CLIs in Go. Talk about some of the packages in the Go ecosystem specifically that help people to build CLIs.
So Go, as you know, has a package ecosystem that supplies functionality and capabilities beyond what Go's core is, which is pretty basic. Some of the more popular ones, two written by Steve Francia, just a huge hats off nod to him, is called pflags, which is a flag and argument package. Go's standard embedded package is not that good, and it's kind of commonly known. And the second package that was contributed by Steve was called Cobra, and it uses pflags, but it is an object command model package. And he developed both of those to support Hugo, believe it or not, the static command line driven website editor. So there's two, and those are basics. We cover those in the book and highly recommend if you're going to use Go to explore those. Others that get really interesting as you look at formatting data, Go does a good job with its JSON handling and formatting. But when you get into things such as terminal graphics, there's a package called Bubble Tea, which you can do some really, really interesting dashboardy type things in a command line that can be helpful. You will also see Table Writer is a popular one that really gives kind of that granular control of outputting data into tables and not having to do a whole lot of wrestling of standard out in the process as a developer. And then obviously there are a number of logging packages that are available as well that make a developer's job easier. So those are off the top of my mind. Those would be my go-tos.
I want to drill down a bit into, you can take these together or in turn, Cobra and pflag. What do they offer to the CLI developer?
So pflag is the flag package. So Go's flag package, as I had indicated, is not as strong as it should be. It's got some challenges with ordering of commands and other things. And pflags is really a robust, if you wanted to write a traditional CLI that had arguments and a number of either short flag, a dash and an initial, or dash dash and word, or a combination of both arguments to a command line, it's a really, really good package to use. As we know, in an object command model where we have a command and subcommand, you will also have the need for flags, or switches we could call them. And so the Cobra package actually embeds pflags, or it uses it as a part of its implementation and gives you the best of both of those worlds. So think once again to our traditional versus object command model. Just traditional, pflags is good enough for you. If you're going to go to object commands, though you could write it on your own, I would highly advise considering Cobra for writing a CLI in that design pattern.
We've mentioned this tangentially a couple of times, but to go head on into this, what is the command object or object command pattern?
As I talked about earlier, it's where you have a command subcommand approach to your command line. And traditionally, you want to build some consistency into that, and you will see one of two patterns. One would be your command line, so it could be a WP or a GH. And then the first object or the first command would either be a noun or a verb. And then the subcommand would be a noun or a verb. So in the WordPress command line interface, WP is the CLI. Plugin would be the noun or the first command, all right, the main command. And then list, for example, which is a verb, would be the subcommand. And that allows you to meet the administrator or developer with a level of predictability and consistency as they maneuver through an ecosystem that they're familiar with, whether it be cloud computing, WordPress, Docker, Kubernetes, Git, etc.
I also want to drill down a bit into bubble tea in that it provides a particular opinionated type of output format. What are some of the options or approaches for output formatting generally in the CLI space?
Yeah, so I'm a traditionalist. I do not claim to be a bubble tea expert, just as a disclaimer to your listeners. But if I think about the CLI, there are two major audiences, right? One is the human user that would need to see output on the screen, and that could be in a table format or a plain text format. And then you have other machines or computers. Traditionally, you will see outputs as CSV, could be JSON. In the case of CLIs like the Ookla speed test, that it feeds a lot of dashboard and data pipelines. It also supports JSON-L. And you could go into any other format that you saw that a machine would consume. But that's the way I would kind of divide the view of traditional outputs from a CLI. As you get into other human user use cases, one would be the REPL, which is the read, eval, print loop. So think of it like a shell, like MySQL. You might choose to have a little more decorative and GUI-like output in an environment like that. And that might involve throwing up some flashing code signals or other things that Bubble Tea could, or graphs or progress bars that Bubble Tea could help you support.
I very much like the trend toward JSON output. I'm sure all of us have written some custom script to parse the output of particular Unix commands, which each one has highly individual and not anything like any of the others. Whereas there are many excellent tools these days for processing JSON. So if we all agree that everything's going to be in JSON, then we can easily write standard tooling to get exactly what we want out of it. It's not really a question, but do you have an opinion about that?
I do. So first of all, huge fan of JSON, and I do think that any modern CLI should have JSON as an output option, not as a default, but as an output option. I'm going to throw a twist into the conversation that in the Unix or Linux world, the expectation has always been exiting an exit code, and that your data is going to be in the standard out or standard error pipes. In the PowerShell world, that changes. PowerShell returns an object, a JSON object, and though it sets an exit code, an administrator has to go look for that. So if you write a CLI today that does not support JSON, you are immediately handicapping yourself in terms of your interoperability in the PowerShell world. Now, I know your listeners who are PowerShell experts are going to say, that can be parsed out and work can be done, but it gets fragile, and it gets fragile quick. And the recommendation would be to provide that option. Back to your early observation, in the original pipeline standard out world, where these CLIs did one thing well, JQ was responsible for that JSON output. I would argue that pattern is probably less powerful today, and that the CLI creator, the developer and designer, should really think through a good, solid JSON strategy for output, because it's expected today.
I'm going to ask you a question about how GH handles JSON, but let's first talk about GH, which is GitHub's CLI, and you feature it in your chapter on All-Star CLIs. What was so great about GH?
So the reason why I chose GH or GitHub's CLI for the book is a couple-fold, but one is that it sits in a really peculiar position of being amongst a great. So if you think about Git and what Git did for the developer community, to come out with what GitHub did as a commercial implementation really focused on developer workflows and how they worked outside of just code management. And to get that CLI right, they could have chosen to step into Git's world and duplicated things that Git did, but they really stuck to that Unix philosophy of saying, let's do one thing well and respect our demarcation point and play well with others. And so it brought parity from the GitHub web-enabled world to meet the developer where many developers operate, which is inside of a shell. And so the modernness there is more from a design pattern, how they chose to handle that. The second modern nature to that is just, how complex the GitHub world is at scale. We're not talking hundreds or thousands or hundreds of thousands of users. You're talking millions distributed across the globe. And they really had to get that right. And in my opinion, they did.
I use GitHub and I use GH. Sometimes I still use the web for something that I could do with GH. Does that mean they failed, or they're just different use cases for different situations?
I think it's a great question. So first, I think that a good CLI, right, is going to reduce cognitive load on a user and be really easy to understand. And one could argue that in both of those worlds, there is a bit of mastery that needs to take place with both Git and GitHub. We've all had to go out to Stack Overflow or look up and help how to do something in particular that was perplexing us. And I'll admit, I've done the same as you, Robert, and gone to the web version to say, I'm just going to go take care of this problem in a way that I can. So I don't think that they failed, but I do think that there is some cognitive headwind that they have presented the user in their implementation. And could that be improved upon? Sure.
We're all using more and more of these large language model command-based interfaces, and we want them to do more things for us. So they are developing interfaces with tools. There are a couple of different approaches. One is get it to use your CLI. The other is you go through a MCP server to a custom API. And we covered this in an earlier episode where it was discussed that the API for the MCP server is actually going to look a lot different than the traditional API. Do you have either a preference or just observation about should AIs be using the CLIs, or are we going to end up writing custom APIs to reach the same backend?
Great question, Robert. I think it's going to be a balance of both. But at the heart of things, what is interesting about artificial intelligence is it is literally, and I'll take, which we highlight in the book, the way that Warp Terminal goes about looking at a CLI and what's capable. We've never thought about a CLI being crawled, right? We've thought about a user invoking help. We've thought about a user taking advantage of autocomplete, but we never envisioned those as being assets that would be consumed by an LLM and be leveraged for implementation. And that's part of one of the considerations that I have a call to action in the end of the book, is to really think out how that documentation and how you're documenting your CLI, because they are going to be discovered. And to the extent that you provide machine-ready documentation, you'll be more successful. Now, should that be the de facto going through a CLI versus an MCP? Boy, I tell you, if I had the answer to that, I'd probably have a different set of tasks on my plate at work tomorrow. I think it's going to be a balance. I will tell you where we overcomplicate things in the industry historically. And if we go proprietary or go down a route that isn't accessible to all, you'll see winners and losers. And for those tools that follow the simpleton approach of the Unix philosophy, right? Being able to operate off of standard text files and being able to work well with others, I think you'll see more longevity. So if I had to put my bet on something, the CLI is probably going to outlive certain MCP implementations. I'm not saying it's going to outlive the MCP, but I think you'll see less friction in environments that go directly with the CLI for certain use cases.
Part of what you said, I wasn't expecting. So to make sure I understood this, when you're talking about a CLI being crawled, do you mean I could tell an LLM, I have this tool in my shell, it's called GH, go figure out what it does, and then the LLM will start running, okay, GH help, GH commands, this is the commands add, okay, GH add help, and it can discover the entire surface area of the tool by reading the embedded self-documentation and train itself up without you having provided any kind of custom adapter Is that where you're going with that?
That's where I'm going with that. And if you think about as a CLI designer or developer, we might give reasonable help knowing that, system admins and stuff, they're smart people, they're going to figure it out. And we might give an example. Well, now the trend in a more modern CLI would be to give a little more detailed help and give a ton of examples, because those examples will be consumed by not just your human users, but they're going to be consumed by LLMs. And you're seeing that. Like Warp is a terminal today. That's part of how they're discovering CLI implementations.
With a command like git, I often ask Claude or ChatGPT, how do I do a particular thing in Git? I believe because Git is so popular that there's an enormous amount of Git knowledge in the AI's training data. It doesn't even need to discover how Git works. It knows.
That would be the second element of this. If you have an open source driven project, right, where that source code is available on Bitbucket, GitHub, whatever it may be, then if it's popular and has, to use a Wikipedia term, if it's notable, it's highly likely that an LLM will have crawled it and understood it. So, for example, we know for a fact that the majors have been trained in the WP CLI just because it's been in existence since 2011. It's PHP, it's open source, it's there. I think where this gets interesting is if you are a company that might have a non-open source CLI or a proprietary CLI, but your user base might be using AI-enabled tools, including Claude Code, including Warp as a smart, intelligent terminal. Are you doing everything you can to make yourself accessible and understandable to the LLM? And hence we entered this brave new world, which is actually one of the chapters I have in the book, that we start to not give the answers to this, but ponder what the future looks like.
To change direction a bit, I wanted to cover authentication and maybe authorization, which every API has to handle that. And therefore, the CLI, which accesses it, must also handle that. How do CLIs do authentication?
This is a really critical area of discussion, and thanks for asking the question, Robert. If you think about in a small captive world, it was okay to go ahead and put in a command that might have included a password and a username, but from a security perspective, that ends up in history, and that's not a good thing. You would also find configuration files in YAML, or you'd find those in JSON. You might find exported environmental variables that would have these. And once again, I'll do something to try to at least centralize this. And I really can't honestly use the word protect, but maybe I'll use the word to try to be responsible with this. But it's a challenge, right? Because a good hacker, they know exactly what they're looking for if they get into a system. Another approach, which is a horrible approach, would be to compile those credentials into the binary. And it takes a good black hat, a matter of minutes, if not, half an hour to unpack that. So we really get back to the semantics of some of the things we're doing in the SaaS environment in terms of how are we using key-based approaches, how are we storing credentials in credential repositories, and back to that Unix philosophy of doing one thing and one thing well. Your CLI should not be raising its hand saying, I am a credential manager, I'm going to do that well. There are other software systems that are better suited for that. And again, in the Unix philosophy, to play nicely with others, a CLI should play nicely with these credentialing systems because they're your best ally in this world that we live in.
You might not be a big fan then of a CLI I use a lot, the AWS CLI, because you have to log in and it gives you short duration access tokens.
It's not that I'm not a fan, and logging in, there's a couple of headwinds that a CLI can create, right? And Claude Code's a good example one, but we'll also talk about AWS. Whenever you're forcing the user to do something that is outside what they ask the CLI to do, so a login is a cognitive load, it's a headwind, it does have impact. But in AWS's world, I understand and respect why they take that approach. And the CLI is being used, right, to interact with workflows and get work done. And that short duration is just part of the world at scale that they live with. Could they have a better implementation? Probably. But I'm not going to go online to criticize it. This is one of the challenges that we face with CLIs.
I happen to know how this works with AWS. It stores the credentials in a directory. So what's interesting about that now is that the CLI is stateful, whereas I think of them from the beginning as being stateless. Are stateful CLIs an actual thing?
So state management is an interesting question. If you think about CLIs such as MySQL, they will rely on state to get their job done, or even some of the content management CLIs will rely on state in a database. I would argue that a CLI that is dependent on state, it might have to have it due to the system it interoperates with, but if it's for something such as a credential or some general configuration parameters, that's probably not the best thing. I do get into state in the book where we talk about the need for state. And one example I give is if you think about doing network work in the Internet of Things and have a small CLI that might be collecting data, it's fair game in C, C++, or Go or another language to use an embedded database to collect that state, process it, but you don't want that to be the system of record. You want to ship that off as soon as possible to a true system of record. So, Robert, I would come back to your question and say, are we looking at things like we would in the SaaS software world of saying, what is the system of record for that state? And is the CLI the best place for that to be managed and stored? And in some cases, the answer might be yes, but probably in most cases, it's going to be a design flaw.
I think about another command like curl, and if I'm hitting an API, I need to usually pass in an auth token as a curl header or as a HTTP header. What the AWS CLI enables me to do is I can log in, and now I can work for 2 hours without having to think about credentials because the credentials are a form of state. So maybe the question is, do you take a stand on per use or stored credentials?
So it really depends on what the workload is. In the AWS environment, you're in there, right, to do work. And I think that is the overall premise of allowing a user to get work done before they exit is a good thing, to where in curl, you're in and out of that transaction, whether you're downloading a web page, you're actually hitting an API, because curl can do a lot of things. It's more transactional in nature. I think it does present a problem, and I come back to SSH. The way that SSH solved this problem is through public and private keys. And I think we are going to continue to want to sharpen the pencil in terms of how we look at authentication and state management and CLIs. There's no one answer fits all.
There's one last topic I want to hit before we start to wrap up. I don't know if it's a CLI feature or a shell feature. How does completion work, and should your CLI provide it?
So auto-completion is literally a file that you would supply with a CLI that would allow the shell environment, right, to be able to read that and autocomplete. And I believe that you should for two reasons. One, it's helpful to the end user. But second, back to this LLM world, to where the more data we provide to external entities such as an LLM, the better you're going to play well in this new world that we're entering into. It's another reason why I like packages like Cobra, that Cobra makes that auto-completion, it bakes it in as a package or as a command to your CLI so that you can run it, create those text files with the autocomplete, and you're off to the races. So it really reduces the workload on a developer to have to implement that.
We may have talked about this already. Do you have any thoughts that you haven't already expressed on where are CLIs headed?
We've talked about in the LLM-driven world, I think that there is going to be a requirement of CLIs to handle non-deterministic returns in addition to their current world, which is generally deterministic. And we're already starting to see those challenges surface in Claude Code, for example. But any CLI that is hitting an LLM and processing structured output, the answer is not going to be the same for every call. And you're going to have to think through that from a design perspective. I also think that if we look at the premise of a CLI to go do something, right, the what, and the developer builds in how we do that, in a regulatory compliant world, so thinking healthcare, thinking banking, thinking a number of worlds, even just with a general SOC audit, you also are going to have to be able to capture in the CLI who did it, when they did it, and more importantly, who authorized it. So now we're getting into workflows. And those logs might not be punched out into standard error and into your general logging format. Those logs might require the CLI designer to provide options out to Splunk or Loggly or Datadog or other places where you can punch an asynchronous JSON payload to actually capture that data. So again, more complications, the more complicated our world becomes. And I think that is why CLI designers really need to do upfront design work to capture everything that they need to be thinking about in their CLI. The last response I would have to that question is if you think about the power that PowerShell has brought to the computing environments, there's an argument that says you can probably get away with 80% of what you need to do by just writing PowerShell scripts. And that scares me, Robert, a little bit. I champion PowerShell. I champion the people who've gotten good at it. But I do think there is still a clean demarcation point between control and workflow, which is in the shell environments, and the work to be done and the testing and rigor that needs to go into an actual compiled, or let's call it versioned in the PHP or Python world application, such as a CLI.
Derick, as we wrap up, where can listeners find your book?
The easiest place to get there is on the web at moderncli.dev. And there are links out to Amazon, Barnes & Noble, and other providers. It is only available in paperback and hardcover, but we made pricing super low because I wanted to make it accessible. Robert, one of the design tenets for the book, and one of the reasons why we selected Go for the examples, it's not about Go, but Go, the examples are in Go, is I truly wanted, whether you be a high school student or a junior college student, and especially if you've got a limited budget, I wanted people to be able to have accessibility to the book and accessibility to the resources they would need to do the exercises in the book, either for free or in a very reasonable price point. And I was really adamant about that as we did this.
Are there any other locations on the web relating to you or your properties you'd like to point listeners to?
Definitely LinkedIn account, Derick Schaefer, to connect up there. On GitHub, I've actually got a couple of plugins in the WordPress space that have actually been approved and will be coming out. And I'm on Twitter, but LinkedIn would be probably the primary place to find me. And my passion and desire to write this book was to capture the history, the evolution of the CLI, and to help people think about how they design them and write the best possible software product that they can for whatever their use case is, whether it be individually or personally, or they're doing something major for their employer in a computing environment. And I wish people the best of the luck and congratulate them if they get the opportunity to work on the CLI project, because they're quite fun.
Derick, I must say it's been a pleasure speaking to you about modern CLIs, and thank you for speaking to Software Engineering Radio.
Robert, thanks for having me.
For Software Engineering Radio, this has been Robert Blumen. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.